Welcome back, GCC. We are still in chapter 5. It's a pretty long chapter, so here we go, some more information for you. Now, the noble gases, if we haven't mentioned it yet, are very stable. They do not react. They're inert. And so they're very stable, and I call them happy. They're happy little elements. The noble gases do not bond with other elements naturally. They're just very, very stable and low in energy and happy. Now, they're all in the last column, and except for helium, they all happen to have an electron configuration that ends s2p6. So they have a full s and p sublevel. Now, helium only has 2 electrons, so it just has a full s, s2, one s2. But the rest of them have a full s and p. So there's 2 electrons in a s, there's 6 electrons in a p, 2 plus 6 is 8. They have 8 electrons in their s and p. So that contributes to them being very, very stable. That just happens to be a stable electron configuration having s2p6. So again, helium is just 1s2. So we call these s and p outer electrons valence electrons. So valence electrons are the electrons in the outermost level for an atom. Everything except for helium in the noble gas column has 8 valence electrons because they all end s2p6. 2 plus 6 is 8. Helium just has 2 valence electrons because it only has 2 electrons to begin with, so it can't have 8. Now those are the outermost level electrons. Now the ones in the inner levels that are filled are called core electrons, and no one cares about core. Let me explain a little more about valence electrons. Valence electrons are the ones that can be shared or transferred, gained and lost with other atoms. And so they're the ones that make bonds. They dictate everything about that atom. They dictate the properties and the chemical behavior of that atom, how it behaves and acts. Let's take phosphorus, for example. Phosphorus, P, is number 15. The electron configuration for phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. The outermost level is the third level. See, phosphorus has electrons in the first, second, and third level, but the outer level is 3. So we have 3s2, 3p3. 2 plus 3 is 5. 5 valence electrons for phosphorus, because those are the ones in the outer level being the 3. So all the electrons that have a 3 get added up together. Again, we have 3s2 and 3p3, so 2 plus 3 is 5. 5 valence electrons. Now the electrons in the first and second level are inside. They're called core. There happens to be 10 of them, but no one cares. Let's try some more valence electrons. Let's look at chlorine, beryllium, and aluminum. I want you to write out the electron configuration for them, and then look at the outer level and tell me how many outer valence electrons there are. So hit pause and look at your periodic table, okay? Really practice, especially if this is an online class, because this is your lecture, so you need to practice this. So go ahead and hit pause for me. Okay, we're back. So I'm going to go ahead and show the answers here. All right, a lot of information here. So chlorine is number 17. So the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p5. So the third level is the outer level. We have 3s2, 3p5. 2 plus 5 is 7. So 7 valence electrons. Electrons in the outer third level for chlorine. Now beryllium is just a little atom. It's number 4. So 1s2, 2s2. It only has two levels, 1 and 2. The second level's the outer level, and there's only 2 electrons in that s. So 2 valence electrons for Be. Now aluminum is number 13. Aluminum's configuration is 1s2, 2s2, 2p6, 3s2, 3p1. So the outer level is the third one. We have 3s2, 3p1, 2 plus 1 is 3. So there are 3 valence electrons for aluminum. So we can write out electron configurations, look at the outer level, and figure out how many valence electrons an atom has. Now that we know how to do that, I'm going to give you a shortcut. The valence electron is also the column number for most of the atoms. For example, if you were in column 1A, that's hydrogen on down, the first column, you have 1 valence electron because they all end S1. 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. They're all S1s. So 1 valence electron. Column 2 starts with beryllium and goes down. The second column, they all end S2. So they have 2 valence electrons. Now notice column 3 is over here with boron. Okay, the boron aluminum column is column 3A. So column 3A has 3 valence electrons. That's because they all end S2P1. 2 plus 1 is 3. So they have 3 valence electrons. Moving it over to the carbon column, which is column 4. Column 4 has 4 valence electrons. Moving over one, column 5A, nitrogen's column, has 5 valence electrons. Again, it's S2P3, 2 plus 3 is 5. Moving over to column 6A, the oxygen column, they all end S2P4, 2 plus 4 is 6. 6 valence electrons in column 6A. Finally, the halogen column, fluorine, chlorine, bromine, iodine, and down. Column 7A has 7 valence electrons. They all end S2P5. 2 plus 5 is 7. 7 valence electrons. And we already mentioned, except for helium, the noble gases have 8 valence electrons because they're full. S2P6, 2 plus 6 is 8. Except helium only has 2 electrons to begin with. So your column number is your valence electrons for the main group elements, the 1, 2, 3, 4, 5, 6, 7, 8. Excellent. So we got a cheat. So again, the exception is helium, only has 2 electrons to begin with, so it can only have 2 valence electrons, not 8, even though it's in column 8A. All right, so how many valence electrons are in strontium, Sr? There it is. It's the second column. So how many valence electrons? 2. Good job. Bromine. Bromine is in column 7A. So how many valence electrons? 7. Argon, right next to it. Argon is in column 8A, the noble gases. So how many valence electrons for column 8? 8, right, 8. What about silicon? Silicon is under carbon in the 4th column, column 4A. So valence electrons is 4, good. And then finally sulfur under oxygen in column 6A. So valence electrons is 6. Yeah, there's your answers. So now you know a shortcut for figuring out valence electrons. That's a great place to have a break. All right, see you later, GCC. Let this sink in a while, take a little break, catch you later.